Section 11, Z-scores, Part 2. And here's some vocab reminders from last time. All normal distributions are the same if we measure in the units of the size of standard deviation about the mean. So changing to these units is called standardizing. So we can compare different data sets by standardizing, looking at and comparing standard deviation. If x is an observation from the normal distribution that has the mean of x bar and the standard deviation of sigma, the standard deviation value, standardized value is x minus x bar divided by standard deviation. And we know that this, again, is called a z-score. Standardized value is the z-score. So how far away you are from the mean. And so z-scores, that's any increment away versus those basic values that we started with last week. Z-score tells us how many standard deviations we are away from the mean and in which direction. So remember, if it's a positive standard deviation, we were above the mean. If it's a negative standard deviation or a negative z-score, we are below the mean. So let's take 1 minute here. We have already saw the z-score formula last class, and you have it now here at the top, x minus x bar divided by standard deviation. So if a data set has a mean of 30 and a standard deviation of 3, calculate these 3 z-scores by plugging those values in. So a z-score of 30, maybe some of you didn't even write down the math that you did there, right? Because it would be 30 minus 30 divided by 3, which is 0. Whereas if I was doing a z-score of 28, it might be in your head like, oh, 28 is smaller than my mean. My z-score is going to be negative 28 minus 30 divided by 3. It's negative 2/3. If you want to reduce that before you put in your calculator, you can. We usually round to the nearest 2 decimal places for z-scores because the z-score table goes out to the hundredths place, so negative 0.67. And then on C, the z-score of 35 would be 35 minus 30 divided by 3, or 5 divided by 3, which is 1.67. On example number 2, we are going to use the z-score table to find how far away they are. So if I'm telling you I want to know what percentage, so use the z-score table to find the percent of observations that satisfy each of those statements below. In each case, I want you to draw a little sketch of a normal curve, which is not provided for you. Of course, when I'm talking about a normal curve, I'm just saying, like, draw yourself something like this, and then you're just going to put a tick mark and estimate in shade where this is at. And so this is a little bit different format than what we've looked at it before. So these are inequality signs. So I want to know a z-score less than 1.40. So what percentage is less than that? So we're going to go from 1.40 to the z-score table. So find the positive side of your z-score table, go to 1.4, and then you're going to be in the 0 column. And you should be finding that that's 0.9192, and so then we move it over 2 decimal places, right? And so then we are getting 91.92%. And let's look at what that looks like on the curve. Okay, so you'd have your normal curve. 0 z-scores is here in the center, a score of 0. So then 1.4 would be a little bit past 1 z-score. You'd have your vertical line that you're going to draw in and then just lightly shade in. And so then you're asking yourself, does that 91% or almost 92%, does that seem logical? Yes, because I'm over my past my mean, and it's this data and everything below. So that like we're trying to make sure that that shading and that percentage kind of correlate and go together. Okay? Whereas on B, this is the exact opposite. We're using the same z-score of 1.40, but now this is a greater than sign. So I'm asking for the percentage greater than a z-score of 1.40. So it's still the same mark on our same place on our z-score table, same vertical line on the sketch of the normal curve, but I'm shading the opposite side, and I would take 100 minus 91.92 to get 8.08% this time. Go ahead and try C and D. I'll give you about 90 seconds here, about 2 minutes maybe. Go ahead and try C and D. Opposites of each other, right? So again, here on C, I'm asking for the percent less than negative 1.81 on our z-score table. And so that is what the z-score table tells us. So it's going to say 0.0351. We move it over 2 decimal places to turn your decimal into a percent. So that's 3.51%. What does that look like on our curve? So you're going over almost 2 standard deviations away and drawing that vertical line, and I want my shading to be on the left because I want to be less than that. So it's just a little bit of that curve, and so remember, kind of just looking to make sure that that makes sense, okay? The opposite of that for D is I want now z-scores greater than negative 1.81. And so I would take 100 minus 3.51 to get the 96.49%. The same vertical tick mark on the normal curve at almost 2 standard deviations below the mean. And then this time, though, our shading would be on the right side. What questions do you have over examples 1 or 2? Okay, go ahead and turn the page in the packet. We just have one more left, I believe. All right, example 3. So a little application problem here. 14-year-old boys have a cholesterol level. Their mean is 170 milligrams per deciliter of blood. And the standard deviation is 30 milligrams per deciliter. And if though your level is 240 or above, you may require medical attention, like medicine, to help balance or offset cholesterol levels. And so on A, it says, what percent of 14-year-old boys have more than that 240 milligrams per deciliter of cholesterol? So we need to think about how we can use the information given with our z-score equation, right? And plug in what we have. So go ahead and write down maybe what your z-score equation or formula is, and pull the important pieces out of the word problem here, and let's figure out what we can do. So with the problem asking what percent is, we need to see if we have enough information given to us to find what? We need to first find the z-score. Okay, we need to see how far away this is. So our z-score formula is observation minus mean divided by standard deviation, and they did tell us that. Okay, the mean is 170. I'm curious about 240 as my observation, and 30 is my standard deviation. So we're going to go ahead and calculate that. 240 minus 170 divided by 30 is 70 divided by 30, or 7 divided by 3, and we're getting 2.33. So with that z-score, what do we do next? Go to our table, okay, and what percentage is that? Okay, 99.01, okay, so less than a z-score of 2.33 is 99.01. So above that would be 0.99. So our z-score, first of all, tells us what is less than when we're on that chart. So we're going to take 100 minus 99.01. That would be a lot of people on medication, right? 99%. But I want to know who's over 240. So I subtract 100 minus that. And so that's less than, or just about, 1% of teenage boys would have to be on, would have to have medical attention for cholesterol levels being too high, based on the data that they usually collect. So then question B is, what percentage of 14-year-old boys have a cholesterol between 170 and 240? What would be our method of attack here? What do we want to do?
Well, the z-score for 170 and then find the percents and subtract them.
Good. So we technically need a z-score for 170 and a z-score for 240. Okay, a z-score for 170 and a z-score for 240. What's the z-score for 170 going to be?
50%. Or for 0.
0. Okay, and that percentage is 50%. Okay, and so we have already calculated the z-score up here for the more than 240, so we know less than is that 99.01, and so 49% or 49.01% of boys have that cholesterol between 170 and 240, so just about 50%. All right, C. So what if we have 500 boys and we have collected their cholesterol levels? How many of them would be expected to have a cholesterol between 170 and 240? So if we take data for another 500 boys, how many of them would be then in that range? What are we going to do mathematically?
Multiply the percent by the people.
Okay, and so in our calculator, we're going to take 500 times what?
0 or 40.
So 0.4901, or like you were saying, 0.4901. So we're going to turn this percentage back into a decimal, okay? And so 500 times 0.4901. And when we are working with people, of course, we're not going to have part of a person, but we would expect that 245 boys then would have that cholesterol levels in between there. Okay, so this concludes our notes here for this portion.